Hello, good morning, everyone. Thank you for jumping on this month's Appgate ZTNA Table Talk session. Thank you, Ixta, for getting us started and organizing us through this process. I'm your host today, Jim Anthony, and we're going to talk about integrating Appgate SDP and CrowdStrike. Interesting concept. I have on the call with me today, one Mr. Gernot Hacker. He is supporting us from Germany. Thank you, Gernot, for joining us. Say hello,
Hey
make sure we
everyone,
can hear
thanks
you.
Jim.
There he is. And we also have Justin Yentel on, who is celebrating a Boston Celtics NBA title this morning. Uh, Go Celts. Let's hear from you, Justin.
Hey everybody, welcome. Thanks for joining us today.
Yep, and again, I'll be your MC for the process today. First of all, thank you everyone for jumping on and paying attention. We are scheduled to go about an hour. I don't think it's going to take that long, but we're going to dive deeply into some of the interesting integration work that we can do between Appgate SDP and other vendors, and very particularly, we're going to be focused on CrowdStrike today as an integration partner. So let's think about this from a big picture perspective. So guys, jump in and help me with this a little bit. But um, I think we could all probably agree that there are some truths about cybersecurity, about how hard it is and complex, but it's also necessary and it's urgent, right? We hear from customers and folks all the time about how, does your product do X or does it integrate with Y? Um, but tell me, Gernot, how often do you run into a prospect that's actually already made cybersecurity choices that they're relying on, and they're trying to figure out how to solve point problems within their choices? Is that something that you see in the field all the time?
Yeah, what I see quite a lot is that there are so many vendors out there that claim they have this one solution covering everything, which in itself always makes me a bit suspiciously, right? And that's what you find out rather quickly, right? There are companies out there that tackle the problem, some of them like ages ago, literally like VPNs 20 plus years ago, right?
Hmm.
And then they figure, oh, something else around. So we claim we can do that as well, right? And some are outstandingly good in marketing and giving you a presentation, but that sometimes doesn't have anything to do with the whole range of capabilities of a product. So you end up with something, and that's what we have quite a lot. And people say, well, the actual core thing, get into there securely. It's kind of there, but it kind of isn't fun, right?
Right,
Or
right.
doesn't work up to the requirements.
Yeah. I think, Justin, I think the categories that we have on that right-hand column, the basic categories, I mean, I think we could probably agree that, identity management is typically something that's different than, say, access management or antivirus. Um, and it looks like I've got a spelling error there. It's supposed to be anti. No, it's right. It just needs a dash, anti-malware. But the point is that I think there are some categories of cybersecurity solutions that kind of don't mix, right? Aren't
Yeah,
those
definitely.
aren't those areas where
Yeah.
we should stay focused?
Yeah, absolutely. And the reality is that even when they don't mix, there oftentimes is information that would be helpful to be shared between those different categories of solutions. And if we could kind of tie that together in an intelligent way, it would help us to make better and more effective security decisions.
I think you're right on. I think you're right on to the next slide. So wouldn't it be nice if one part of your cybersecurity world was actually aware of another? Wouldn't it be nice if your identity management solution was actually aware of maybe your antivirus health, right? Or something like that. If authentication were context aware of the device itself that you're using, just because you know your login and your password doesn't mean that you should be allowed to use every device that's out there, right? Um, Another example, what if network access were actually contextually aware of the health of the device that you're on? And that's what we're going to key in on here with Appgate SDP and CrowdStrike. So let's dive a little bit deeper on this thing. So first of all, this is not a CrowdStrike commercial. Nobody on this call is a CrowdStrike expert. We are simply users of CrowdStrike. We understand what it does. We understand the value that it adds to our world. Um, CrowdStrike is one of those multifaceted platforms where they've got EDR capabilities and SIM and SOAR capabilities, data protection, exposure management, automation, intelligence, artificial intelligence. There's all kinds of things that you can get out of CrowdStrike. But the bottom line is that it's centered on, it is a robust platform. It's cloud oriented, but also agents and clients that run on end user workstations and servers within your environment. The bottom line is that all of this interesting stuff that CrowdStrike does is really focused on determining whether or not the device itself that that software agent is installed on is actually trustworthy. Is it free of viruses? Is it set the way the corporate settings require it to be set? Meaning, is the local firewall enabled? Is the hard drive encrypted? Things like that, right? Anything else to add to that, Gernot? Any other thoughts about what that CrowdStrike Falcon agent might be looking at?
As you were mentioning, right, we are not the expert for the product in the field here, right? But me having done, like, when I started working with vendors like an antivirus in like ages ago, in 1999, obviously Posture is relevant, and CrowdStrike definitely took that to the next level, right? With giving you a platform and then giving you the means, because of being cloud-based, to get basically feedback of how other nodes are doing, right? So this gives you a completely different picture, obviously. It's also a very convenient tool to look in different like categories of what's relevant to you regarding posture of device. And that's a whole different level than purely antivirus was back then, right?
Yeah.
So it's definitely valuable if you want to know what's going on your endpoints.
Yep. Okay. I agree. So again, not a CrowdStrike commercial here, but we look at CrowdStrike as one of these important critical components of your overall cybersecurity picture. There are other platforms that CrowdStrike competes with as well, but really the idea here is that we're going to leverage CrowdStrike to determine a device's health and then use that information in other interesting ways to decide whether or not it's trustworthy. So let's keep going, and very quickly, we're going to give a quick overview of what Appgate is. Why does Appgate actually exist? I think, Justin, you're prepared to take us through a couple of these slides, right?
Yeah, Jim, you bet. And so really, Appgate is a ZTNA solution that helps you to marry the things on the left side of this diagram here to the things on the right, really. So really what we're trying to do is to help you to identify a combination of users and devices and other things, and really incorporate all of the sort of the stuff in the middle there, right? So everything should revolve around an identity-centric approach. You should know as much about the users and the devices that are connecting before granting any kind of access. We should employ a cloaking mechanism to hide all of the infrastructure. The solution should employ the principle of least privilege, obviously, in a zero trust network access solution. Flexible and agile, right? Being able to be programmatic and respond to changes to things that occur in real time. And then really basically the goal is to help you to securely manage the access for all of the things that you need to control access to on the right side. So things that are in your traditional data centers, your public cloud environments, and even your SaaS applications.
So Justin, I know that one of the things we talk about in the market is, we obviously with Appgate SDP, we play in the zero trust network access space. But what's this universal ZTNA concept? Can you touch on that for a second?
Yeah, Jim. I think that in our industry, unfortunately, a lot of these terminologies get overused and kind of bastardized to a point where, they sometimes don't make a whole lot of sense. But universal ZTNA, in my opinion, is one that really kind of stands out. And the universal part of that, the key is that Appgate being a universal ZTNA solution, it was designed to work from anywhere, on any device, to help protect any user or any device's access to anything, regardless of where those things are. Some of the other vendors in the ZTNA space really are kind of geared more towards being remote access solutions exclusively. And Appgate SDP was really kind of designed to help you to replace even things like NAC solutions, and even to mitigate the need for things like MPLS and some other technology, legacy technologies there as well. And so kind of that's what universal ZTNA really represents, is really the ability to use that solution anywhere to protect anything.
Okay, all right. Let's dive into the architecture a little bit of the Appgate SDP product.
Yeah, so Appgate is really comprised of two core components, and they are a client and an appliance. And if if you take a look at these, the client can actually come in a few different forms to help you solve different business problems. There are full Appgate clients that you can deploy on any major operating system. We support Windows, Mac OS, Linux, Chrome OS, as well as mobile devices running Android and iOS. We also have other client solutions to help you solve other business problems. So we can help you secure access to things like IoT, or to and from things like IoT devices, legacy operating systems, containerized applications in Kubernetes clusters. There's more to that as well. On the appliance side, our appliances are actually delivered to you in the form of an appliance image. And that image can be deployed in any data center or cloud environment. And the appliances can be configured to serve several different functions. And so while you can see those listed in the lower left here, on the right side of the diagram, the two most important functions of that appliance are depicted graphically. And so an Appgate appliance deployed as a controller is a policy decision point. This is where users and devices are authenticated and authorized. You can think of the controller as if it's the brains of the solution. And when an Appgate appliance is deployed as a gateway, it's a policy enforcement point. Those gateways would be deployed in line between users and resources that you need to protect, and ideally as close as possible to the sensitive resources themselves. Now, right out of the gate, all of those Appgate appliances are cloaked using a technique called single packet authorization. Single packet authorization effectively makes all of the Appgate appliances completely invisible to a port scan, and therefore they are not susceptible to things that traditional access solutions are. So things like VPNs always have an open listening port that must be accessible from anywhere in the world. And that means that not only can your end users connect, but also the bad guys can discover that open port by way of a port scan. And therefore, they are vulnerable to those other types of things like denial of service attacks and zero-day exploits and other bad stuff. So the point is Appgate's virtually immune to those types of problems. Now, when we dive into how it actually works, the first thing that occurs is the Appgate client will reach out to the controller using SPA. And after the controller validates that that very first message is properly signed and includes a valid SPA key, it essentially agrees to communicate with that specific client. And then we can validate the user's identity against any identity solution on the back end that talks LDAP, Radius, SAML, or OIDC. But from an Appgate perspective, kind of as I hinted at in the previous or a couple slides ago, we consider identity to be much more than just a question of who's the user and what groups are they a member of. We think that identity should be a multidimensional profile that also incorporates any of the context that you care about when determining what a user or device is allowed to access. So things like device posture, network location, geolocation, time of day, and even attributes from other third-party tools and solutions might be important. And that's part of what we're going to talk about here today, is that those attributes from other third-party tools and solutions, obviously, we're going to take some of that information from CrowdStrike and show you how Appgate can help with that.
Okay,
after evaluating that, and after evaluating all that information, that's okay. And after evaluating that information against the policies defined, the controller will hand back to the client a set of tokens called live entitlements. And those are going to give the client some instructions on what resources the user is allowed to access and information about the gateways that protect them. Again, using SPA, the client then establishes a connection to the relevant gateways and uploads that live entitlement token, which the gateway will then use to make a determination on which resources the user is allowed to access. And then ultimately a dynamic segment of one is built where the traffic is encrypted from the client to the gateway, and the user is allowed to access only the protected application to which he or she is entitled, while all of the other applications remain completely invisible in accordance with that principle of least privilege. Throughout the duration of the session, Appgate will also continuously monitor for any change in context, and if necessary, it can dynamically adapt the segment of one. And so we can dynamically revoke access and even redirect the user to some sort of a self-remediation resource as necessary. And if we zoom out to look at the bigger picture, ultimately Appgate can help you connect any user or device to any application or resource in any data center or cloud environment. And so as we look at this really simple diagram, what you see here is an end user that's sitting at her desk, who in this case has been entitled access to 4 different things that live in 4 different environments. But from her perspective, all 4 of those applications and resources is available simultaneously from that one endpoint that she's sitting at. That's all made possible by way of a patented multi-tunnel adapter built into the Appgate client that allows for Appgate to dynamically route the traffic to the appropriate environments based on entitlements that she was served. And that's all going to add up to a solution that can deliver at massive scale with ultra high performance. And Appgate is natively very resilient, highly available, and nearly infinitely scalable.
All right. I think
And
that's a really
yeah,
good overview, Justin. And
yeah,
that's the basic infrastructure it takes to make Appgate work. But
yep,
I think we need to have a discussion around a deeper level of understanding of how this policy engine and the how does the policy engine work? What are the things that drive the policy engine? So within the policy engine, we have something that we call claims.
yep.
Gernot, can you help us understand some of the differences between user, system, and device claims and what these things actually are?
Absolutely. So yeah, you've listed those already. So we have three flavors of claims we look at, and the name are pretty indicative about what they're supposed to deliver to you, right? So user claims is basically any user attribute you have in your user directory you can map. By default, if you set one up, you obviously have stuff like first name, last name, username, email addresses. I always say most prominently security group membership of a user, which you can conveniently use to create later on a policy that says if a user is in security group, I don't know, on-premise thinking here, Active Directory Administrator, put that as a part of policy that gives you access to RDP into Windows directory controllers, for example, right? System claims very basic stuff, really. It's basically a fingerprint, which device called in at which point in time, from which public IP address, and what internal IP addresses and MAC addresses the device is. So pretty straightforward, core basic hardware information. Also about details about the operating system version and some granularity. And device claims gives you more depth information about the device. And there is a template piece of information in there, and I mixed it up with system claims. I mentioned already. So the operating system information is in a device claim, right? And if you want to know something that goes beyond what comes out of the box, you can even stretch the limitations of what you want to know about, right? And simply adjust the system to give you something that's relevant to you, right? And on top of that, you can ignore stuff in there, or you can get as granular if you want to, right? So this system, it behaves as you need it. I always say a core system setup going, top of an hour or so, right? But you can dive into something that is very specific to your needs, and you can spend more time in getting that granular, right? So it can be a tool for everything, straightforward and growing to your needs in terms of complexity. And that's basically all built on those claims that give you the data points to make a decision if you want to give access or not. And one very charming thing we have is we can attach to a network access attempt a condition, right? And this is also where kind of the CrowdStrike thing comes into play. So it's not just giving connectivity, it's also attaching strings to something that results in you have to provide MFA or something, or just give an information to user why access is denied instead of just not being able to get there, resulting in a help desk call, nothing's working, right? With this, you get some feedback to the users why they cannot connect to something even. And that's all
Okay,
built on those claims.
so thanks for that explanation. So let me summarize a little bit. So there's three groups of claims. User claims come from the identity management system. System claims pertain mostly to the network, like the default gateway and the geo coordinates and things like that. And device claims really come from the device that the user is using at the moment that they're trying to access the system. You use the phrase out of the box. How many claims are coming out of the box? How many claims are if you modify nothing and make no adjustments, what do we collect by default? 30, 40 different claims across this spectrum? Is that about right?
It would be in the area of like 20, 30-ish, right?
Yeah.
Yeah, that's
And
what we're
then
talking device claims, right? So
yep. And
quite
then
some
which
stuff already.
So I think user claims and device claims are customizable. You mentioned that as well. So you can add additional claims checks. You can look for new values in your identity management system, maybe custom attributes that you've added there. Device claims, I could look for a running process, or I could look for, the existence of something that's pertinent to my world, right? So completely customizable, right?
Yeah,
Um,
within the limitations of a specific platform, right? As you know, on a mobile platform, what you can do is basically next to nothing, because for that you're supposed to use a MDM. With regular desktop OSs, we can give you quite a lot if you need some specific information.
Right. And it's fair to say that whether you capture the claims, whether you decide to use the claims in your policy engine that we'll get to on the next slide, when you capture them, they get logged. right? So all the claims that you've captured, whether they're standard claims that come out of the box or they're custom claims, everything's getting logged anyway, whether you decide to use it in the policy engine. So you can look backwards over time and say, how did this claim value change for this particular user over a certain set of, days or weeks? So that's an interesting concept as well. And then, of course, just because you have the claim, now you can use them. You can start to mix them, match them. You could mix a set of user claims with a set of device claims to build your policies. So let's talk real quickly about how do we use these claims to make policies. Justin, give us a quick overview of how that might work.
Yeah, it's pretty straightforward actually. Basically, all of those claims, any of those pieces of information that Appgate collects and ascertains about the users and the devices, can be built into your policies as access criteria, essentially. So we could build a policy that incorporates many even different types of claims. So, for example, we might use a group membership claim from the identity provider that says that you must be in a certain group. We might also look at things like a running process that is on the endpoint and either blacklist or whitelist that running process. We might also incorporate, as we're here to get into eventually, information from CrowdStrike to actually build that access model and say that, CrowdStrike must have evaluated you in a certain way before you're allowed any kind of access. And those policies ultimately tie you down to an entitlement, and that entitlement defines the targets on the network that you're allowed to interact with. And we do that by way of, as you can see here, IP addresses, subnets. We also have some more dynamic methods of defining that access using metadata in cloud environments and so forth to dynamically resolve resources and more.
Okay. All right, that's great. So basically what we discussed here is that claims in those three buckets can be used in policies. Policies will allow you to access entitlements, and entitlements are how you define the destinations that you're providing protected control to. Basically, who gets access to what. Interesting. So Appgate ZTP, what is this? What is this thing? I think Gernot, you were ready to walk us through what ZTP really is. I think it's been part of our world for about 2 years now. Is that about right? Tell us a little bit more about what ZTP does.
Yeah, so this it stands for Zero Trust Platform, right? And the idea is there coming from a product that's partially driven by a high level of nerdism in terms of figuring things out, right? Which translates to like 3-4 years ago, it was quite complicated in some points, right? And we made a deep learning curve in terms of make it more usable. And this is the next iteration of that. ZTP, the idea there is giving a platform where you connect your what we call collective. It's an Appgate installation, right? And the first layer of that is that you kind of attach your Appgate controllers to the platform. So they give a heartbeat and a health status and a convenience look, but more prominently, what we previously did and still can do is to attach to different systems based on figuring out how the API works. For example, what we going to show you today with CrowdStrike, right? Which could be a pretty painful and technical process. And ZTP is our answer to customers asking, couldn't that be like less painful, right? And that's the point about ZTP. To have a core dashboard where you see your environment at a glance, it's healthy or not, right? Or you should have a closer look. But then again, being able to integrate other products that give you value add in identifying if you want to give access or not, right? So
Okay.
that's roughly that.
So effectively, we've taken the idea of API-based integrations with third-party products like CrowdStrike and written the code to facilitate that integration, but embedded that code in the ZTP platform and make that available to our customers via what we call an adapter, a risk adapter.
Exactly. And we
Perfect.
break it down to you only having to provide a bunch of API credentials you create in a cloud platform of like CrowdStrike, punch it in, and you're good to go. And we can make use of that information of that's collected by a CrowdStrike agent on your desktops out there.
All right, so I think that's a great explanation. I'm going to stop sharing, and Gernot, I think you're prepared to walk us through, starting with, I think the CrowdStrike console itself. let's get a quick sneak peek into what that CrowdStrike console might think about my particular laptop. Is that fair?
Yeah, let's go for it. Now, let's keep fingers crossed that I'm sharing the right screen. So you see some kind of dashboard here?
We do see
looks
it,
like
yes, sir.
Yeah. So what you see here, just from an organization point of view, on my screen here on the right-hand side, you see me being connected through the Appgate client, which I need to do to be able to access the Appgate admin interface in the first place, right? And here you see the CrowdStrike dashboard. So actually, I'm not able to go into more details of that. It's one of those dashboards. Well, as a CrowdStrike customer, you probably know what you get there, right? You get an overview of most relevant aspects of your system, typically giving you an alert if some device is in a messy state, right? And those states you define here in the element in CrowdStrike, that's called zero trust assessment, as you see here on top of the screen. Let me see if I can actually highlight that. Here you go, right? And here you see something that's relevant in CrowdStrike, right? You have an assessment score, and now my pointer is giving up on me. Annoying, right? So here you see those scores that you define. It's a rather obscure thing. You got some out-of-the-box stuff in there. But if you go further down here, you see here one host, which is actually Jim's device, and I can show you that later in the Appgate interface as well.
So
But
this is
here you
what
see
my this is what my device is reporting to CrowdStrike. The agent running on my device is reporting into the CrowdStrike engine my device's health. Was that the score that I saw there on that line out to the right?
Yeah, exactly. So what you see here is basically the one-line information about the CrowdStrike internal host ID, the host name coming from the US, what operating system, what's the platform, and here you see those assessments: operating system, sensor, and based out of that, my pointer is killing me today. Well,
it's okay. We're
that's
following
the
your
first,
hand. It's all
but
good.
it's what it is, right? And the overall risk score, right? And this consists of elements you configure down there, right? You have those items, operating system and sensor, right? And it's just different elements in there where you look at all of them. And here you make a criteria regarding what's relevant to you and what's your priority. And based out of all those elements, CrowdStrike calculates that overall assessment score, right? So that's a bit what you get from CrowdStrike. And obviously, it would be nice to know to work with that information before you give someone remote access into something, which brings Appgate into play, right?
Perfect. I like it. So overall, I've scored 99 according to CrowdStrike out of
Yep.
what looks like to be 100 as a possibility. So I've missed one or two of the rules down below, and I ended up with a 99 score. So how does that get translated? How does that flow into ZTP? What does that look like from a ZTP perspective?
Yeah. So for this, let's move over to the CTP, and welcome to being prepared.
It's okay.
Say what? I had it open for the last 90 minutes, and that's what it's giving me right now. Oh, this is so annoying sometimes. Really?
Justin, maybe you grab the screen. Can you pivot real quick and show us what ZTP looks like?
Yeah, sure.
That is ridiculous.
That's okay, Gernot. That's why there's 3 of us on this call.
Yep.
the fun of live demonstrations, right? Gernot,
So
go ahead and stop sharing.
Yep.
Stop sharing.
I
I got it.
Yeah, you go.
All right.
And we'll come back to you, Gernot, after Justin shows us ZTP.
All right, so this is the ZTP console. As you can see here, I am signed in, and so we're looking here at the risk engine rules that Appgate has configured for our collective our Appgate collective that we're showing you here. And so in our ZTP console, as you can see here, I've got a risk engine rule for CrowdStrike ZTA, and that is kind of the score that Gernot was focusing on in the CrowdStrike console just a moment ago. If we dive in here on this rule, as you can see here, it's actually pretty simple to configure. So when we configure an Appgate ZTP rule, we basically just give it a name, and then we define some very basic information here that points at essentially our CrowdStrike information. Obviously, we're not showing you our client secret here, but otherwise, you can see how that is configured. And then back here on the rule configuration, As you can see here, there's a risk mapping down below here. And we've these numbers, you may notice that they correspond to the numbers that CrowdStrike reports as that ZTA score. So anything that's between 180, we currently consider to be a low risk score. And we consider anything between 79 and 30 to be medium risk, and high risk to be 29 or 0 up to 29. I should have said it the other way around. But the whole point here is that we can also edit these risk mappings if we want to. So if, for example, I wanted to consider anything down to a 70 as being low risk, and then modify my medium risks upwards from there, I can change these risk mappings to meet my needs.
And this is all, Justin, this is all adjusted in real time? How does that work? What's going on there?
Yeah, so really what happens here is that Appgate periodically polls your CrowdStrike console for essentially a list of all the devices that are reporting, that have a Falcon agent installed and are reporting information up to CrowdStrike. And we kind of pull that information back from CrowdStrike again periodically. And so when an end user signs in from a device that has the CrowdStrike Falcon agent on it, we're going to be able to tie that ZTA score that CrowdStrike has assessed to the device, and then use that internally within Appgate to make some access decisions.
Okay. And before we move into the Appgate, back over to Gernot, can you pop back to that services list, back one screen? I saw there was some healthy and some unhealthy in there. Give us a little rundown of what that means.
Yeah, and really this just means that, well, we are not a Trellix customer here at Appgate. So this was basically just an Appgate, or excuse me, a ZTP adapter that we configured that just for, pointing out some various concepts here, but we don't actually have a score coming back from Trellix because there's not any information there that's available to us in this particular case.
Perfect. And then while we're on the ZTP console itself, maybe give us a couple of other little things that we can do with ZTP. What are some other uses of this console for our customers?
Yeah, so I mean, obviously there are other risk engine rules here. So Appgate has native ability to tie into Intune, for example, and we can look at OS versions and see if your patch levels are up to date and so forth. And there's a few more things that are available here, and way more that's on the truck as well. So there are other risk rules that we can connect to here. But also, in addition to that, within ZTP, you also have the ability to kind of manage SDP collectives. So if I wanted to stand up a brand new Appgate controller and use that for testing in a lab environment and connect some new gateways that I deploy to it, I can very easily click Add New and request essentially a hosted Appgate controller be stood up for me. Appgate will get that up and running within about 5 or 10 minutes, and it'll become available to me to very quickly and easily test out some new features or plan for an upgrade and things like that.
Okay, that's awesome. And then I would assume that hosted concept is the foundation for some managed services that we can actually provide to our customers too, right?
Yes, exactly.
Perfect. All right, I think at this point we're going to switch back to Gernot. So while we're doing the screen share thing, so basically what we've done is we've taken a look at CrowdStrike. We've looked up an individual device, happens to be my device. We now understand the overall score of my device according to CrowdStrike. And then using ZTP, we can see that CrowdStrike is being queried and pulling those scores back in. Gernot, how does that show up in Appgate now? What does my score look like in Appgate based on those low, medium, and high risk ranges?
Yeah, we'll do. So as you can see, an anonymous tab solved my issue. It was something with the Okta token, but it's what it is, right? So what you have here, right, is coming from what you have just been shown by Justin, is this risk score bit, right? So now let's start first off with me trying to get the Zoom tab out of the way. Let's just work through tabs. So it should be tab. Here we go. So if I open up the overview of the active sessions running, I will show you Jim's system. So he's connected over here, right, from his device. If you're a fan of remembering weird strings, you might recognize that from the CrowdStrike dashboard before, right?
Yeah.
But what you see in here is more details of a system. So first glance overview about details. Who is it? From which device? What's its Appgate internal IP address? An internal identifier. And where Jim's machine is connected to. And you see here this multi-tunnel capability, so it's different network locations. But let's come back to the decision-making points. You learned about
as an
system.
administrator, you have complete view into everything that my device is allowed to do, the things I'm connected to. You have a view of all the claims that have come back from my login attempt earlier this morning, all of that, right? That's what we're looking at here?
Exactly. And
Okay.
here you see what you actually have access to. And this is an example of those conditions. You see some red lights, some green lights. And this means is with green light, obviously, let's just have a look into that right away, right? You see here this logic element, this condition, and this means always, so it's met. And here you see the firewall rules to systems you have connectivity to. And on the other hand, you have something with no access, means you lack some information. Those are the conditions we touched before. And this is where this risk scoring element comes into play. So let's have a look at what we have here from the device. We talked about the system claims, again, very basic stuff, and device claims. And in here, you see further down the road, CrowdStrike information, right? You see here this CrowdStrike ID, which is basically the one of Jim's device. That's this identifier, the CrowdStrike internal one, right? And then you see here, well, helpful, it's installed. As such, well, nice to have. Does it give you anything? Yeah, you know that it's running. What's more fun is knowing about this risk score bit. And that's actually attached to Jim's identity. So we have this built-in element of risk in here. And here you see the different providers we have for that. Here you see Intune, and coming back to thing before here, and I managed to put it out of the picture. Today, I'm really hitting myself in the foot. Hang on.
Just Gernot, you're just proving that this is absolutely live. This is not a recording.
Okay. Here we go with the second tab. So this is actually what you see here with those different adapters, right? And these you see here, and that's a bit in previous iterations of the product, like 2-something years ago, before we had ZTP, this stuff you had to create manually. Now we have this hardwired in the product, and you either use it or not, right? And here you see basically with the Trellix one that, if you remember, it's unhealthy, right? It basically gives you not enough data to compute anything, right? But here we also have the CrowdStrike element, obviously. Here you see the CrowdStrike ZTA, and here you see the Falcon Insight. And you see the score is 1. And the reason for score is 1 is exactly this mapping in here, right? If you go to ZTA, this is where this 1 comes from, because we defined it in here with those different risk scores from CrowdStrike, right? And given that Jim's risk level is 99, we translated somehow into a 1. And now I show you somehow. This is in the risk model, right? So based on that, you get this 1, 2, 3, which is then the risk score in here, right? And 1 is good to go for everything. You can fully trust this device. But you may say, well, there might be some situations where I say, I'm not overly happy with the system state, but I want to give means to a remediation server to update stuff that's missing, for example. So you still want to give some connectivity, but not like to your HR system anymore, right? And this is where the risk matrix kicks in. So it is a very straightforward way to get going with this value-added information from CrowdStrike to make a more granular decision if you want to give access to something. And this is where we design the risk metrics, right? So you see here in the access section of the product, one bit that's called the risk model, right? And this is exactly that. It's a very straightforward metrics. When you say you have a risk level of the user device, high, medium, low, again, coming from these definitions you set in the ZTP platform based on the risk score of CrowdStrike. And you have a resource, a network resource, that is also high, medium, or low sensitivity. And here you can very easily, just with clicking, select those different options, saying, I want to, if the target is high sensitive and the user is at high risk, deny at any given point in time, right? And you have intermediates where you say, well, if this is the case, if both risk and target sensitivity are medium, go for user action, which you simply set down here, typically MFA, right? And you select that. Or you just say, it's just a remediation server or a honeypot even, I don't know. Even if the user is high risk, you give access to that, right? So this is how you can simply set up based on these elements that you get from CrowdStrike without bothering too much about how to connect into that, and simply facilitate it very easily, right? And how do you actually use it? You do that in a policy, right? If you remember, policy is where you define who should get access to what, right? So let's move over to a policy then and set one up, right? So we go for an access policy, and in here you give this thing a name. And here you do the policy assignment, right? You say, I want to give access to if someone has successfully authenticated. I'm just randomly clicking here, right? So we have quite some identity providers in there. But the relevant bit is that in here you assign an entitlement, right? And in an entitlement, then in turn, you can say you want to verify that risk score, right? And having said that, let's move over quickly to an entitlement then. Create one here. And here you just define, like you would know from a firewall, what kind of actions should be allowed, right? Network traffic with those protocols and whatnot. On top of that, we have this capability to connect into multiple network locations, which we call sites. So you basically tell here in which site should this entitlement live. And here comes in this risk-based access, right? So you can select here what's the sensitivity of that resource. And you say, okay, this is medium sensitivity.
And that's how you tie that back to the matrix in, is that right?
Exactly. This is where these things fall together, right? So if we go back to that matrix bit, this is exactly what's being verified here, right? You define here that this is a medium sensitivity resource. And over here, you say, okay, it's medium sensitivity. And if the user is at low risk, as your device would be right now, you will be allowed access. And if not, you will ask for MFA or a remedy action saying, well, you have to reach out to help desk or whatnot. And that's basically how those pieces fall together.
So any of the entitlements that you define, if you use that matrix setting of a high, medium, or low sensitivity based on the entitlement definition there, you can apply this matrix of deny, user action, or allow, and it can be based on a ZTP rule. I think that's the one thing that you didn't show, just above where your mouse is there in the user risk source. Yeah, show us what that looks like.
Yeah. So yeah, my bad. Sorry for that.
That's okay.
So what you see here is something that should look familiar already by now, right? So if we move back over here, you remember those risk engine we can configure, and those kick in here, right? So here you say, well, for this matrix, it should be applied based on CrowdStrike ZTA. And that's all you have to do, right?
So this becomes a global setting for all of those entitlements, and you can very quickly apply that risk score from CrowdStrike to all of your entitlements based on their sensitivity settings that you set up, right?
Absolutely. And the only bits you have to do is you have to select it here, right? You have to set it up in here. And the setting up in here is even very easy as well. I mentioned it previously. You just have to give the thing a name. You select this adapter and provide API credentials into your CrowdStrike backbone. And that's all you have to do. And that's awesome. Previously a rather painful way to get there, really.
Yeah, that's pretty awesome. So I'd like to shift gears over to Justin for just a second. We do have some extra time here. Justin, if you would, I think Gernot showed us an easy way to integrate all of our entitlements based on their sensitivity into a CrowdStrike score. There's a more detailed way as well, right? Could you walk us through the very detailed way of maybe integrating the CrowdStrike score with some other elements of information from that claim system that we talked about early on?
Definitely. I'll share my screen again. All right. And I'll try to keep this as concise as possible. So really, so when we want to kind of incorporate a bunch of these different elements, right, and I'm going to just add a new access policy as well. And let's say I was creating a policy for my HR users. All right. So I give my policy a name and I come down here to the assignment criteria section. And when I add new here, so I've just created an HR policy. So obviously I probably want to make sure that my users are members of the HR group. And obviously I probably have a longer group name than just HR, but just for simplicity's sake, that's what I'm going to do there. Now, I also want to validate that the CrowdStrike data is as we expect. So I can configure a ZTP risk rule as being the one of the sources of truth here. So I can say that the user must have a medium or lower ZTP, CrowdStrike ZTA risk score. And then if we also want to incorporate in perhaps that Intune adapter that I mentioned before. So I want to make sure that the user's device is registered with Intune and it's within compliance with the policy. So I've just added a third thing that must also evaluate as true here. We can add even more stuff here. So those looking at things like the running processes and local host stuff. Perhaps we even want to look at geolocation and validate that the user is in, a certain area of the world. All of that stuff can be incorporated, and we can also customize this logic to meet our needs as well. So, perhaps we want to evaluate that the user must be in the HR group, but then either they can have one of these two must evaluate as true as well. We could do ands and ors to make that all come true there. And then ultimately, we're going to assign one or more entitlements by either a name or we can use tags to define which entitlements those groups of users would get access to as well. But ultimately, this is how we can kind of tie a bunch of different criteria there together to define access very granularly.
And so I think it's safe to say that based on how you created this example, it's not related to an individual user. So HR might go hire 2 or 3 more people or summer interns or something like that. As long as they're put into the HR group within your identity management system, they meet the CrowdStrike criteria and the Intune criteria, they'll qualify for these apps, right? That's basically how this works.
That's how it's intended, yes. So it's really simple, and you don't have to actually update anything on the Appgate side when you do add those new users to your HR group in your identity source of truth.
All right. So one more thing while you've got the screen there, we've kind of connected an Appgate controller through ZTP to CrowdStrike.
Right.
What happens if there's something broken along the way? What happens there? In other words, now I have a policy that's dependent upon a CrowdStrike rule coming back. What happens if that, say, ZTP can't reach CrowdStrike for some reason? What do we do there?
Yeah, so that's all done in our global settings in the Appgate admin console here, where we integrate with ZTP first. And then when we enable that risk engine integration, as you can see here, there are some fallback risk levels that deal with various scenarios. So there are certain scenarios that are possible, they could occur, right? So first of all, if the Appgate Zero Trust platform is not reachable by the Appgate controller, how do we handle those types of events? And do we want to treat those devices that are new devices that are trying to log in as being a high score, medium score, or low score? So basically, this is kind of like break glass type of settings, right?
Okay.
If device risk data is not available. So if for some reason the Appgate controller is able to talk to ZTP, but ZTP doesn't have enough data about your particular device, how do we want to handle that scenario?
Okay.
And this is where that comes into play. And then the final one is basically if the rule or adapter is not working. So this would be kind of the scenario where Appgate's ZTP console can't reach, for example, the CrowdStrike console. And how do we want to handle those situations? What should we treat those devices as high, medium, or low score? So we get basically the ability to define what the fallback scores would be so that, do you want to default allow those devices and trust them, or do you want to, in our case here, we're treating them as high risks, as you can see. So we would basically, any policies that incorporated that information, most likely the devices would not be able to get access.
So basically, we're giving our customers the choice of failing open or failing closed, or even failing medium, if that's
exactly.
a thing, in each of these 3 different scenarios, and you can mix them up and match them and all that. So that's powerful stuff. I love that. Thank you for walking us through that. I think at this point we're really getting close on the time. I'm going to wrap us up and get us to the end here. Let me jump back into that PowerPoint deck real quick. So we've kind of walked through the flow of things. Let's just give a little quick recap. And guys, tell me where I go wrong on this thing. So this all happens when the user logs in. And then it happens again periodically throughout the session, and the user doesn't have to do anything, and they don't even really realize that it's happening. So what is happening? So the idea is that the user starts their computer. When that computer starts up, the CrowdStrike Falcon is installed. It starts up, it starts running, it analyzes the device, and it reports home the posture of that device. That all happens. That's a CrowdStrike thing, and that's what happens. The user gets their desktop, they log into that Appgate SDP client. They might have had their credentials cached in that client. They might have it automatically log in with those credentials, or they might manually launch it and log in, provide those credentials. After the SPA key is exchanged, and thanks, Justin, for walking us through that, the credentials are validated. The Appgate controller gathers device posture based on that claim system that we talked about. The ID of the device is then handed off to ZTP, assuming the ZTP integration is set up in your Appgate collective. The ZTP then makes a codeless API called a CrowdStrike with the device ID. CrowdStrike returns that score from 0 to 100. In my case, it was 99. That's translated to a low, medium, high concept and handed back down to the Appgate controller in the form of that claim that Gernot showed us. From there, all of the user, device, and system claims are passed through the policy engine. Anything that comes back true will result in entitlements being sent to the end user, and then those entitlements flow down to the client. They're parsed, gateway connections are established, tunnels are established, firewall rules are done, and the user has access to stuff through that patented multi-tunnel concept. And this happens in a matter of seconds, right? It's amazing. So through this integration, what we've now done is we've taken what CrowdStrike knows and understands about a device and used that as a level of trustworthiness before we grant access for that user and that device into the network. That's a powerful statement and a codeless integration, if I do say so myself. Anyway, thank you guys for joining us today. If you're interested in diving a little bit deeper into Appgate itself, we do have a free ZTNA trial out there, so you can bounce out to that URL you see on the screen, or just hit appgate.com. There's a banner across the top that you can click on to get there. Free 30-day trial, no contracts, no fees. Just jump out there and get started. And then, of course, if you found this useful and interesting information coming out of our table talk, we're trying to do one of these every single month, and we do a different topic every month. Next month's topic is already set. We will be talking about a resilient zero trust ecosystem using some auto scaling techniques and some adjustments to the infrastructure based on workload. So again, if you're interested, pop out and register for that July session. And from there, we appreciate your time and energy today, and thanks for jumping on with us. Hopefully you found it interesting. Adios, guys. Thank you for jumping in and helping me today.
Thanks all. Bye.